As you recall, our last lesson was on arithmetic sequences. And remember, what makes an arithmetic sequence is a common difference. So today we're going to talk about geometric sequences, and they're much like arithmetic sequences in that there are patterns, but the patterns are not related. The pattern is not related to a common difference, but a common ratio of consecutive terms. So in other words, if you look right here, you take the second term divided by the first term, you'll get a ratio, a value, a number. Then take the third term, divide by the second term, fourth term, divide by the third. So just like with an arithmetic sequence, you take the term that's in a higher position in the sequence and subtract the one immediately below it to get the common difference. And you divide that way to get the common ratio of the geometric sequence. All right, now, this is another important formula for us to find the nth term. You know that's what we're always interested in doing, is finding an explicit formula. This is an explicit one. Explicit formula for finding whatever term we want to in the sequence. And so for a geometric sequence, a sub n will be the first term times the ratio raised to the n minus 1 power. All right, we're going to work a lot of problems today, but in the interest of time and trying to keep this video not quite so long, I'm going to skip some of the problems. And example 1 is one that I'm going to skip. It's a little proof showing you how this formula came to be, why it works. I'm not going to do that. It'll be posted on Schoology for you in the notes, so feel free to look over that if you're interested, but not doing it here is not going to have any impact on how you do in this lesson. So we're just going to roll right on and go to example 2. Okay, we're going to write the first 5 terms of each sequence. All right, we're given a sub 1. We know the ratio is 1/10, so we'll start with a sub 2. So that's going to be, remember, a sub n is the first term times the ratio raised to the n minus 1 power. So in terms of a sub 2, it's going to be 5 times our ratio raised to the 2 minus 1 power, which is 5 times 1/10. So that gives us a half. All right, a sub 3 is going to be first term, 5 times the ratio raised to the second power. So that would be 5 over 100, which is 1/20th. So we can keep going in this manner, or we can just realize that to get every successive term, all I have to do is multiply the previous one by 1/10, right? Think of it recursively and it makes your job a little bit quicker. So I'm just going to say a sub 4 is the previous term, 1/20th, times the ratio, 1/10, and I get 1/200th for that one. And finally, the fifth term is going to be the previous term, 1/200th times 1/10, and that gives us 1 over 2,000. So again, even though I do have an explicit formula, and I used it in the first 2 terms I was trying to find, I can use that explicit formula, or in this case, I can see that each successive term is just going to be the previous term. Oh, sorry, it's negative 1/10. Oops, I think I messed up here. R is negative 1/10. So let me go back and fix these. So that'll be negative 1/2. Negative 1/10 squared. That one's going to stay positive. If I multiply 1/20th by negative 1/10, that one will be negative. And then that'll be negative there. So that's going to stay positive. Okay, sorry about that. I think I got it all straightened out though. All right. Example B, I'll do 1 or 2 of these. No need for me to do them all in this recording. You can do them all once you get the hang of it. So first term times r to the n minus 1. Actually, this one is a little bit different, so I think it's going to be easier. All we have to do here is just plug in, n equals 1, n equals 2. So that's what I'm going to do instead of even thinking about that explicit formula. So the first term is going to be negative 4 to the 1 plus 1 which is negative 4 squared, which is 16. Second term, going to be negative 4 to the third, which is negative 64. Third term, going to be negative 4 to the fourth power, which is 256. So again, this is one that's going to alternate between positive and negatives. And I'm going to stop there at 3 because these numbers are going to get pretty big, and I don't have my calculator with me.